Welcome to IPMWORKS e-learning modules. My name is Tito Caffi and I'm from Università Cattolica del Sacro Cuore in Italy. This video is part of Module 4, Integrated Disease Management, and in particular it will present Chapter 4.5. It is the case study in horticultural crops about processing tomato. Processing tomato, it is a very relevant crop around the globe and in Europe, and particularly in Italy. In northern part of Italy, we are growing almost 40,000 hectares under processing tomato with a quite huge production, 3 million tons of tomatoes for different results in concentrate, pulp, and paste. Roughly 50% of the overall Italian processing tomato, 25% of the European production, and nearly 7% of the world production. So we have a huge focus on this crop, and of course it is of quite relevance to manage them properly and implement IPM in a proper way in this crop. To face this task, we are talking about a decision support system that has been developed following the multi-modeling approach we already discussed in the module 4.3, and in particular pomodoro.net, that is tomato.net. So it is about the main aspect that we need to take into consideration. So disease management on processing tomato only when necessary. So the practical implementation of IPM principles. The aim, of course, is to reduce disease as much as possible, controlling cost for targeting to achieve economical sustainability, reduce the exposure to chemicals, of course, for the operators, for farmers, but also in terms of risk of residues for the final production. So fostering social sustainability. Of course, reducing the negative impact on the environment. So targeting environmental sustainability in order to better perform with the crop, not only from a technical point of view, but also for a general sustainability principle. So with the four steps of a decision support system, we have to monitor the cropping environment, so the situation in the field. We can define the field we are managing with its own characteristic, type of soil, exposition, irrigation system, how we are managing the crop. We have to insert, and we can give to give into the loop of the decision-making process and decision supporting system all the information about all the treatment in terms of action, not only referred to specifically to fungicide application, but also to agronomical, technical intervention that are developed, that are carried out into the field. We have, of course, since the approach of multi-modeling is to consider to put together as much information as possible, we have models for phenology. So the plant development is simulated starting from the transplantation into the field in order to calculate the leaf emission, so the canopy development, the flowering emission and flowering duration, because of course it is a critical period of the season. For many point of view, fertilization, So providing nitrogen, it is crucial, and we have to follow the phenological stage. Providing water, we are used because of climate change to severe drought. We have to watering tomato field, and we are facing a scarcity of water. So we need to optimize as much as possible the withdrawal of water for watering our field. It is important to reach to have timely and precise information for doing this. Of course, fertilization, it is an agronomical technique, but it is also ruling the density of the canopy. And so, as if you want, secondary step, the risk for some diseases, and in particular for the spread of some diseases. And of course, also pest. In some cases, pests that are vector of a disease. So it is a very complex situation, and we have to keep the balance, the equilibrium of the system as much as possible. Then we have abiotic stresses that must be managed. We have, of course, the drought, so the stress due to need of water, and we have to keep along the season the watering at the proper level without creating an up and down of the watering, because we have some abiotic stresses like blossom and rot, which are of course due to the specific susceptibility of the variety, but also to the type of water, the equilibrium in calcium availability and uptake from the plant, and of course the availability of water. So having such an indicator like physiopathology like the blossom and rot can be of great importance for understanding when and how much to watering our field. We have here three outputs of this model with three examples with three different variety. You can choose whatever you want. As an example, I think Guadalete is quite an evidence of a very susceptible variety to blossom and rot. So if you are in a critical area where you know that you have such a problem, probably Guadalete is not your first choice. By the way, you can see there is, of course, a great effect of the variety, but having a model, we can follow during the season the risk dynamic, and so taking appropriate decision. This model can be useful also for checking your situation using weather data to simulate, for instance, for the next season to change the variety and see, okay, what can happen if I'm changing this variety with this or that. And then we have the, let's say, proper phytopathological simulation with different diseases, downy mildew, alternaria, so the late blight or the early blight, the alternaria leaf blight, many different bacterioses that are affecting the crop. We can use information retrieved by those models in order to follow the infection period, so the risk, the level risk due to the environmental condition, your field, your management techniques, the weather, of course, combining fungicide treatment, so specific treatment applied in the greenhouse before transplantation, for instance, but also, and of course, during the season, We can apply a model for dynamic of efficacy, fungicide residual efficacy after an application, and we can see how much the crop is protected. When this curve is going below 80%, it means that it doesn't mean that we don't have any efficacy of the treatment, but it means that the residual efficacy is decreasing. We can combine all this information to give a scenario to the grower, and the grower will take uh, action. We put into practice appropriate actions. So I'm presenting you some use of such a type of decision support system into a live project that is an agrestic project, the agrestic live project that is still ongoing. It will be finished in 2023, at the end of 2023. We are comparing conventional cropping system, the CCS in blue here in this slide, with nitrogen and carbon efficient cropping system. We are trying in this project to maximize the yield in terms of production, quantity and quality, of course, reducing as much as possible the application of nitrogen and incrementing the carbon storage in order to reduce greenhouse gas emission of the crop. And here we have the feedback. This is just one field, one locality in the Emilia-Romagna region. We are showing the same field, let's say. So we have two fields, one close to each other with the same weather. So same output of the model, but two different management. In the first one, you can see the blue area that are all the treatment applied on a weekly basis by the farmer. In the second, in the green ACS scheme, the farmer was using alone the decision support system, but he was applying three less treatment. Why? Because he considered the coverage, the protection provided by the previous treatment and the level of risk, and he could manage differently the frequency of fungicide application. We also manage differently the fertilization, irrigation, and so on, but I would like just to show you some results about this testing. The yield was more or less the same, even if a little bit less in terms of tons, but if you look the quality, so the bricks 4.5% higher, a little bit less of acidity with the pH, and a little bit more in terms of color, make an increase. This combination of characteristic in the berries harvested after the season give an increase of 9.1, so a little increase in terms of yield. Then we can quantify also the better management with 30% less in terms of plant protection product use, a little bit less in 5%, but it is not bad in terms of water use efficiency, a reduction in fuel consumption, and a reduction in fertilization. So it means that we improve the general quality of the processing tomato field. Thanks a lot.